Hello, so today we're going to take a look at, let me get this screen over here. We are going to be taking a look at the normal curve day 1. So let's have you write that in your notebook, normal curve day 1. And then the first thing I'm going to ask you guys to do is you don't have to copy this down, but I want you guys to take a look at this image and in yourself or share in the chat which one doesn't belong, and think to yourself as why. So if we were to take a look at this image here, you might have a variety of reasons. You know, they don't both, this one, you might say they're all even, or this one dips down in the middle, this one goes up at the right, this one kind of curves up. So if you remember from last year, this bottom D, it's called skewed to the right, it's higher there. And this other one, we could say it's straight across. This one, it's higher on the ends. But what we're going to focus on today is a histogram that looks similar to this, where if we were to write on it here, which it doesn't look like I'm able to, we would say, oh, it looks like it's kind of a curve. And that is what we're going to look at today, is these ones that are a curve. So if you remember from last year, this is called a normal curve. And within a normal curve, if we were to graph all this data here and make a histogram just like we saw in our warm-up, the mean goes right in the middle, so that average. And then if you remember last year, data spread out, and we look at something called the standard deviation, which tells us how spread out data is. And what we did often last year is we marked, I'm going to put this little sigma here, and just so I'll make a little key, this sigma means a standard deviation. And it helped us measure like how far away from the mean is it. And in a normal curve, we measure out 3 standard deviations. Oops, that's a 2 and 3 standard deviations on each side. And within the normal curve, some information happens here. Within 1 standard deviation, 68% of all the data falls. So let's say we were to measure heights of people and it made this nice standard curve, normal curve. The mean height is in the middle. And then within 1 standard deviation, 68% of the heights are. Within 2 is 95%. And within 3 is 99.7%. Now, a lot of this stuff makes a lot more sense if we put some context to it. So what I'd like you to do, pause the video here, and I want you to write down this problem. All right, so we're looking at blood pressures, and we're looking at what's called the systolic blood pressure. So like when you measure blood pressure, it's like 130 over 85 or 115 over something. But we're looking at that top number if you've ever gone to the doctor and had your blood pressure measured. So the first thing we're going to do to help us with these problems is we are going to make a normal curve. And within a normal curve, our mean goes in the center, so 120. And we're going to do this normal curve, and we're going to put a standard deviation on each side. So we have 127, so we add 7 again, add 7 again, and then we'll do the same thing and we'll subtract 7. So we got 113, 106, and 99. So here's our normal curve. And I could write that this is 1, 2 standard deviations, and 3, 1, 2, and 3. So our first question, what percent of people have between 106 and 134? So if I was to take a look at that, here's 106, here's 134. So we'll notice both of those are on the 2 standard deviations. So if I go back up here, well, within 2 is 95% of our data. So what percent of people have between that would be 95%. Now the second question, what percent of people have higher than 113? So if I was to look down here, here's 113. So I want to know what percent of people have higher than that? Well, it falls on a standard deviation, which is good. And if we look at one standard deviation, well, that's 68%. So, well, what do we know? Well, we know if I was to draw a line right up to here, so here on over is 50%. So we really just need to figure out what percent is right there. And if we go back up here, well, we can do that math. 68% is between 1, and we know it's symmetric. So if I divide 68 divided by 2, that means 34% is here, and 34% is here. So I'm going to go back down and say, okay, well, I know that this is 34%. So our total has to be 84%. So that's kind of the cool thing about this is we can break this down into all sorts of percents. For example, if I was to look at what's outside this, we know 99.7. So if I did 100 minus 99.7, I get 0.3. So 0.3 is outside. So, you know, we're talking about the outside parts right here is 0.3. Well, it's symmetric, so I divide it by 2. So that means out here is 0.15% of the data. There's a tiny, tiny amount, so very tiny amount of people are outside 3 standard deviations. Well, let's see if we can break some more of this down. Well, if I look at 95% of the data, so if I did 95 divided by 2, I get 47.5. So what that means is, and this is where it gets a little messy, in this yellow chunk is 47.5. Well, if I know that that's 34 minus 34, I get 13.5. So right here is 13.5. Well, we could figure out this other chunk. I know 50% is above and below, so I could do 50 minus 34 minus 13.5 minus 0.15. And if we do that, we got 50 minus 34 minus 13.5 minus 0.15. We have 2.35 is in this tiny chunk. So we can really break down to these exact percentage of people that fall there. So the second problem we're going to look at, and again, I'm going to have you pause the video and write this down. All right, so I hope you guys are impressed with my bowling scores here. I mean, I'll be honest, I do barely bowl over 100, but decided to make me look like a good bowler here. So again, first thing we're going to do is make a normal curve. So here is our normal curve here. Bowling goes in the middle, our mean, excuse me, so 200. And our standard deviation is 14. So 1, 2, 3, 1, 2, 3. And I'll start adding 14. So we got 214, 228, 242. And then we'll start subtracting. So 200 minus 14, 186, minus 172, minus 14, 158. Whoops. So we have all this stuff written out. So we got 1, 2, 3, 1, 2, and 3. Okay, well, let's see. What's the question asking us? What percent of our games are between 158 and 242? So 158 and 242, well, that's 3 standard deviations. Well, that's pretty easy. So that's got to be 99.7%. Because again, I can scroll back up here. Between 3, if they lie exactly on 3, is 99.7. What percent are over 172? So here's 172. So what percent is over? Well, we know the middle half is 50. And then we need these other two chunks here. So if we go back here and we can look at this, well, that's our 34 and 13. So this chunk is 34, and hopefully you can see. And then here's 13. I think it was 13.5. Whoops. Let me check. 13.5 and 34. So if we add all those together, 50, 60, 70, 84, 94, 95, 96, 97.5. What percent are less than 186? Well, where's 186 here? Well, 186. So we want to know what is less. Well, we know what is over. If I go up to see what's over, that percent is over. So 50, 60, 84% is over. So 100 minus 84. So that's got to be 16. I mean, the other way we could do it is we could go back up here and we could add 13.5, 2.35, and 1.5. 13, 14, and we get the same thing. So we got 16%. And the last one.